This one, it was 57%, but that's not very good. It's pretty easy. How are these, how many of these 4 expressions are defined? Defined means that it can be done, can be calculated. So if we just go for a little refresher here, if you are adding or subtracting matrices, they need to be the same order. So these are not the same order. So this one is not defined. So not defined. The next one, if you look here, I'm just going to, because this is a good sort of little summary, this is what we call scalar multiplication. And scalar multiplication is when you times everything outside the matrix. It's just a scalar number. This one here is a scalar number. So when you just times that, this one can be done, and like that would just be 6 like that. So this one is defined. Okay, when we have multiplication, remember when we have to look at the order. So this is a 1 by 2 and this is a 2 by 1. For it to be able to be done, remember we have to have these two equal, which it is, and then our order will be a 1 by 1. So this one is defined, okay? And then just to go over another little bit of theory, if you have a power, so only square matrices can be raised to a power. So only square matrices can be raised to a power. So that one is undefined. So this one is undefined, not okay. So how many was 2? The matrix A and the element in row I and J. They'll always say this. So I indicates the row number, okay, and J indicates the column number. That will always be the case, and they will always state it, okay. So the elements in matrix A could have been created using this rule. So for everyone, this rule's got to work. So if you think about, you have to, unfortunately, with these ones, you sort of got a trial and error. Like you just got to trial and see which one it doesn't work for. So these are good ones you could do in reading time. Hopefully you could keep it on. So if you look at this first one, this one has I equals 1 and J equals 1. So just to show, if the formula says 2I minus J, what that means is for this one, it'd be 2 times 1 minus 1. So that does equal 1. So this one is okay. That matrix could use that rule to create it. So then here, if you look in this one, the second one, you've got we've got I equals 1, and then we've got J equals 1, J equals 2 here, and J equals 3 there. So we know the first element in the matrix has to be 1, yeah? So if you look down, all of those are okay. You don't need to test it again. You tested that theory because it's still in row 1, column 1, isn't it? So don't worry about testing that one. So I'm just going to test the next one here and see what happens. So if I test the theory, so remember 2I minus J, for that second one, it will be 2 times 1 minus 2. Does that equal 0? Yeah, it does. And then you quickly test this one. If I do that one, it'll still be 2 times 1, but it'd be minus 3 in this case. So that would be 2 minus 3, which does equal -1. So this one is okay as well. So it's not that one. So now I know, also, I know that second, see if I'm in this row 1, column 2, that should be a 0. So I already have tested that one, so I know that's right. I don't need to test that again. So let me go, when I get down to this one, this is I equals 2 and J equals 1. So I'm just going to test that 3, and it'd be 2 times 2 minus 1. Does that equal 3? It does, so that one's good. Then if I test Now, because I've tested that 3, I know that if you're in column 1 and row 2, it should be 3. So I don't need to test that one again. So I'll just test this 5, which is in I3, J1. So this one would be 2 times 3 minus 1. Would that equal 5? Yes. So I'm pretty much said yes to all of them. I know this one can be 3. And now, hopefully, I know this one should be my wrong one because it's worked for everything else. So this is I2, J2. So let's do the formula for that. It'd be 2 times 2 minus 2. So that would be 4 minus 2. That is 2. That's not what that one is. So there's the one that it could not be. So the diagram shows a competition between these people, and it says each player played each other once. The winner is indicated with the arrows, blah, 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 blah. And then it says the winner is the person who has a 2-step dominance over the loser, and the matrix is. So we want to find the matrix, the 2-step dominance matrix. So for us to do that, in our calculator, we'll have to put the D, the first dominance matrix. So over here, let's go through it. Now, we can see down there what order they've put everyone. So I'm going to copy that order when I'm working it out. And remember, whatever order you go across has to go the same downwards. So if I look at M beat P and N. So they beat P and N. Now, when you have a dominance matrix, you never play yourself. So I'm going to put zeros down the leading diagonal. Now, N only beat P. So N beat P and 0 and 0. I think O beat everyone. And then P beat no one. Okay, so that's my dominance matrix. So then you see what all I have to do, and you can see I've written that down here. Here's my dominant, and then I've squared it, and I get, this is D squared. So I've done that on the calculator. So D squared equals, and then you get E. Okay, so the table below shows the number of players at a sporting club who received each 4 different match payments for the match last weekend. Okay, the matrix product that displays, now this is where you want to know. So your answer, when you multiply something, it says the total number of players. So that's one answer. And because they wrote and, that means you want and the total value of payments. Okay, so in your answer matrix, you want two elements, yes? So what you can think about is you either want a 1 by 2 or a 2 by 1, because I know I want 2 elements. So you can quickly check, this is a quick way to do it as well. So you've got a 4 by 1 being multiplied by a 1 by 4. It is defined, but it's going to give a 4 by 4 answer. So I'm going to get rid of that one, okay? And then, so then I can look at, look at the one underneath. This is a 1 by 4 with a 4 by 1. It's going to be a 1 by 1 answer. That's not what I want. So I'm going to get rid of that one. Okay, so then I have a look at the rest will probably produce. So if I double check that, so I've got a 2 by 4 and a 4 by 1. So that one will produce a 2 by 1. So that could be, it could be that one. This one's a 1 by 4 with a 4 by 2. So it could produce 2 answers. So I'm happy to have a look at these ones at the moment. I couldn't get rid of them straight away. All right. So when you think about it, what you want to do is you want to have the answer with all these numbers added up. That would be one answer. If you think about it, that's going to be total number of players. And the other element is you're gonna want like you want 50 times by 7 and then you add all them up, yeah? And 200 times by 12 and you would add all that. Wouldn't that be all the cost? That would be the total value, yeah? That's how I'm going to get all the total value. I'd times that one by 15 and this one by 3, and I would add all of them up, okay? And that would give me the total value. So have a look at manual multiplication and see what happens. So if I look at, I'm going to go down to E just because I'm here. Now remember, if you go, if I do this one, when you multiply, you remember you go these numbers get multiplied with those numbers and then you add them together. If you look at that, that is going to give me the total number of players, isn't it? Because I would have, in my answer, this answer is going to be a 2 by 1. And my first answer would be 1 times 7 plus and all of that. Does that make sense? Yeah, the run and dive. So that will be my first element. Then if I look at the second, I'm doing the second row, this second, then I would be row by that. I'm going to go 50 times 7 plus. That's exactly what I want, isn't it? That's saying what I want to happen. So this ends up being the answer. So these are manual multiplication questions. Okay, so consider the matrix QP equals R, where Q is a row matrix. So what you have to think about with that, when they say, oh, Q is a row matrix, so if you had matrix Q, a row matrix means its order must only have one, it'll be 1 by something, okay? So it's a row matrix with no 0 elements, okay? And P is a permutation matrix, okay, and a 4 by 4. Which of the following equations involving various elements in matrix QP and R could be true? So what you need to do is always write out what you know. So I'm going to go, all right, I've got Q times P equals R. All right, I knew that Q was a 1 by something, but then I knew P was a 4 by 4. So therefore, this has to be 4 because I want, because it produces an answer. And I know R is going to be a 1 by 4. Okay? Now, remember when they give you these little numbers, so say up here, when they say P24, that means the element in row 2, column 4. Okay? So that's what it's telling you. So remember that Q had, no zeros. Okay? But remember, P is a permutation matrix, and a permutation matrix only has, permutation matrix. Think about the facts of a permutation matrix. It only has 1s and 0s, yes? And the 1s, there's only 1 per row and column. So that's a fact about a permutation. And remember, permutations just help you shuffle the elements of the other one. So we are just going to shuffle around Q, really, and that'll give us R. So if you have a look, when they say element P could be 2, 4, could be a 3, it can't be because we said only 1s and 0s in P. Only 1s and 0s in matrix P. Okay, so it's not that. When we say R, they're saying element row 1, column 5. There's no column 5 in matrix in R. It only goes up to 4, so you can get rid of that. Now, Q1, 2, so the element in Q at row 1, column 2 equals the element in R. Now, this could be, I don't know, but it could be because it is shuffling it around. And so it may. So I'll just leave that and have a look. I'm not sure with that one. If I look at the other one, Q13. Now, it told me up here that Q cannot have 0 elements. So that one's out. Now, if you look at this last one, they're adding elements of the permutation matrix. Now, if you have a look, they've got the same column here. So if they're adding, those elements are both from column 2, they can't both be 1. Because remember I said over here, you can only have one per column. So this is not true, because one of them can only be a 1. The other one might be a 0. Okay? And that's because of this fact here. Okay? So in the end, our only one that can be true is that. Okay, so matrix K is a permutation matrix. So in your reading time, this is what you do. You have to think about a permutation, because you can't pick up a pen or anything. So have a think about it, and you're thinking, right, permutations, only 1s and 0s, yeah? And remember, there's only 1 in each row and each column. And when you're doing your study, write these things, because then you remember that fact and you don't have to keep looking it up, and when you're in the exam, you're going to be quicker. All right, so we've got matrix K is a permutation. Matrix M is a column matrix. So I just like to, a column matrix means there's one column. So it's a something by 1. And it's multiplied by matrix K. So really, we've got matrix M getting multiplied by matrix K. Now I know M is a column matrix, but I can see K, and K is a 5. So K is a 5 by 5. So I need to put K at the front because it wouldn't be defined otherwise. Sorry. Does that make sense? So it's going to get multiplied, but this is a 5 by 5. So if I know that this has to be a 1 here because it's a column, yeah, I'll have to put the K in front. And then, so this is a 5 by 1. All right. Now, if you look, and you multiply that and you obtain matrix P. Now, they're being nasty, and you can see in the exam they're starting to be nasty. Just don't forget that K is the permutation one, yeah? K is, even though they said the answer is P. Yeah, they're calling that one P, but that's not the permutation one, the K is. So remember, permutations, they just shuffle around elements. So if you think about it, I'm going to, I'm just going to rub that bit out so I can put it in. So I'm going to multiply it by M here. I'm going to write M is a column matrix. Now, what will happen is M will have its elements here. So M would be row 1, column 1, and this would be element row 2, column 2. This would be row 3, column 1. This would be row 4, column 1, and row 5, column 1. So that's all the elements, the 5 elements in M. And you can see what you're going to do is you're going to multiply it by that K, and you end up with this P matrix. So if we go over, and then P would have whatever its elements are. So if you look at this, this would be the P1 1 spot, this would be the P2 1 spot, this would be the P3 1 spot, P4 1 and P5 1. But we're going to shuffle around. So remember, with permutations, remember you go run and dive. So because it's the 1 in this first row, the 1 is in the third one. So that means this third one down will show first up here. So M31 is going to go in there. If I did the next one, because the second one is got a 1 on it, it means the second element in that M is going to show. So that one would be M21 shows there. If I look at the next one, the fourth element has the 1 is on the fourth one across. So it'd be the fourth one down. So it'd be M41 there. The last one is, then we've got 5, and then we've got the first one. Okay, so it said when this happens, where did M31 move? Where did it go to? It went up to here, so it went to P11.
P1?
It's in P11. Look. So 2 types of computers, laptops and desktops, can be serviced by Henry, Ivan and Jean. The matrix shows the time in minutes it takes each person to do a laptop or desktop. Matrix Q shows the number of laptops and desktops at 4 different departments, and there it is. Now, a calculation that determines the total time. So this is where, with these ones, you really got to work out what the actual answer needs to look like. So the calculation that determines the total time that will take each of Henry, Irvin and Jean working alone to service all the laptops and desktops at the 4 departments is. So if you think about it, it would be like those 3 people go out and do all the jobs, all the servicing. How long is it going to take them? So if you think about it, you're after either a 1x3 or a 3x1 because you want Henry, Irvin and Jean and their total times, okay, each. So there you go. So sometimes a quick way is to look at what your answer is going to be. So if you look at these ones, so this one is a 1x4 and this, now if you look at what they're doing here, it's a Q, which Q is a 4x2 with the transpose of N. So if N is originally a 3x2, then the NT is going to be a 2x3. All right, so this one in here would be possible. It would produce a 4x3 if you did that bit in brackets. So the total answer is going to be a 1x3. So that one's okay. So that could be something. So this is something you could do in reading time, if you like. If you look at this one here, this one, we already know that Q by T is going to be a 4x3. If I look at this as a 3x1, this is going to give me a 4x1 answer. So I don't want that. So I'm going to get rid of that one. I don't want that one. This one, when you have N by Q, QT by Q, if we look at this one, N is actually a 3x2 and Q transpose would be a 2x4. So that is, oh yeah, that would be a 3x4. So the answer of that would end up being a 3x4 along with Q, which is a 4x2. So but this is going to end up with a 3x2 answer, which means I don't want that either. So I get rid of it. So the quickest way to do this is first to check what you need. So, and then work through them and find out which one gives you a matrix with the elements that you need. And then when we did that, because by the time we checked them all, only A. Now that's probably something you could do in reading time. If you just take your time, you could think about it. But anyway, know that you're going to do that, target it out, and then just double check. You could type that whole matrix equation in and make sure it gives you the total time and just logically work it out and see if it's right. Okay, with exam 2, matrix C shows the nightly cost in dollars of 3 types of accommodations at a ski resort, at a hotel, motel and apartment. The Dwyer is planning to stay at the ski resort for 5 nights. Complete the matrix equation to show the cost of staying at each type of accommodation for the 5 nights. So you want to just really times that by the cost by 5. So we just want a 5 there. And then we end up, when you times that matrix out, you get that amount. So that would be, if they were to stay at a hotel for 5 nights, it'll cost them $400. The family has decided to stay at the motel for 2 nights in an apartment and in an apartment for 3 nights. Write down the column matrix A, which the product matrix CA. So that means they're going to multiply C, which I'll just put in front because they said they're going to do it. So that'd be 80 140, 270. That's C. They're going to multiply it with this A, and it would give, that gives the total accommodation cost. So you can see this is a 1 by 3, and this is a 3 by 1, and it will end up with a 1 by 1, which is good because that's the total cost. So when you run down, if you think about it, they're going to say 2 nights in an apartment, and what is it? Oh, sorry, no, stay at the motel for 2 nights, and apartment for 3. So because they don't want to stay at the hotel, I'm going to put a 0, because when you go run and dive, you'd go across here and down here. Now this is going to be the hotel, motel, apartment. So I want to times the motel 1 by 2, and I want to times the apartment 1 by 3. So that's the answer for that. All right, that's a little bit of manual multiplication. Sometimes if you just write how they said, because when they said product matrix, that means you're going to multiply C by A. Just write it down on your paper. Question 3. Students from a nearby school spend 1 term skiing at a resort. 1 year, the school term begins on the 16th of July and ends on the 22nd of September. The resort has 3 different types of ski runs: beginner, intermediate, advanced. Each day, students use 1 type of ski run, and below is the transition matrix to show how they change their choice. Okay, let SN be the matrix that shows the number of students at each type after n days after the 16th of July. So the 16th of July is SO, yeah? So how many skiers choose the same ski run on the 17th of July? So because they said it begins, so this is 16th of July. If you need the 17th of July, you've just got to do, it says how many choose to do the same ski run. So if you're doing the same ski run, that means you're going from B to B. So if you look at that value up there, B to B is 7.7 or 70%. So what you're going to say is 70% of the B ones on the day before, which is 210. So if you change that, that's 0.7 times 210, that equals 147. Now, if I do the intermediate to intermediate, and I'll highlight that number up here, that's also 70%. So it'd be 0.7 times the intermediate number, which is 190, which equals 133. And then we've got the last one. We've got advanced to advanced, which if I look is 0.8 of the 80. So if I times 80, and that equals 64, and then you total all of them up. So the answer would be 344 don't stay at the same thing. So you just got to be careful, probably read wrong. Got to look at same to same. They're going to choose the same. So you just have to do individual, look at the transition. Consider the skiers who are expected to choose the advanced ski on the 17th. So that's S1. It's of those ones, what percentage of these skiers also chose advanced ski run on the 16th of July? So what you're looking at here, if you look, first of all, let's find out what S1 was. So S1, you'd go transition times SO, and then we end up with this. Because they're saying of the ones who are expected to do the advance. So when they say this is July the 17th, it says of the advanced ski runs. So that means this bottom number. So 102 is on the 17th were advanced. And it said how many of them came from advanced in the day before. So we already saw up, so what we're looking for is, so the percentage equals the amount over the total times 100. So we need from A to A is 102. Now, we need to find out how many went from A to A, but we could see that. They've already asked me up here, A to A. We know that was 64, went from the same run, and then we know there was 102 in total, and we times by 100, which equals 63%. It said whole number. Okay, it said in this question, it says, what is the maximum number of students expected to ski at the intermediate ski run on any day? So when we look at our state matrices, whatever one it is, so say state 0, whatever, we've got beginner, intermediate, and advanced. So it said, what is the maximum number of students we ever see at this spot? So it is a little bit of how do you know. Some people think it's not asking you to go to the long term, because it might not happen in the long term, might not be the largest day that we ever saw. So all it is you need to start at 0 and look at all the consequential states. And what's going to happen is you're going to then see that it does change, but there was somewhere there was a maximum. So if you look, this is SO here, and so this was beginner, intermediate, and advanced. So you can see it had 190 to begin with, and then it said on any one day. So then this one was the next day, and you can see at intermediate it had it went to 12, and then if you go to the second day, intermediate had 218, and then it went day 3, intermediate had 219, and then by 4 we see it dropping, intermediate, and then it keeps dropping. And then I just double checked, I did go to the long term, and I see that it's dropped down to 205. So there's no other way but to keep checking it. And like once you see it dropping, okay, then you can say, all right, I think it's going to drop. Check the long term, it's dropped. So what was the highest time it was ever? It was on this day 3, wasn't it? 219. So 219 was the nearest whole number. So in the this year exam, okay, at the end of the school term, students vote for who they want the captain to be, ski captain. 3 students, Ali, Lee and Max, are all nominated. 7 days before the end of school, students were asked who they plan to vote for. The following table shows the candidates and the number who plan to vote. Each day, all students are asked who they will vote for. It's expected that the students may change candidate from day to day, and they go, here's the following, and they said some percentages are missing. So you're already told, it says how many students plan to vote for Ali after 1 day. So this is SO, you need S1, but you need the transition. So we'll have to set up the transition. Now I'm going to use the same pattern that I've got, if I've got Ali, Lee and Max the same way, and then I've got Ali, Lee and Max. So I just have to go through all the stats and fill them in. So if you go 40% of students who vote for Ali next day, so that's 0.4. If I look 30% who vote for Ali vote for Lee, so Ali today, Lee for next day is 0.3. Sorry, you guys normally have this AL down the other side. Probably help. I'll just pop it down the other side for you. Okay, the next one, 50% of those who vote for Lee the next day. Lee to Lee is 50%. So just be careful that you're popping the right ones in. The next one, 30% of those who vote for Lee vote for Max. So 0.3 Lee to Max, 0.3. and just circling back with the colours. 50% who vote for max to max the next day. So max to max, 50%. And then the last one here, they said 20% max vote for Lee. So max to Lee, 20%. So that was 0.2. So there were some missing, which they said that. So I've got 3 missing. Now I can work them out because transitions have to add up to 1. So this one's 0.3, this one's 0.2, and this one's 0.3. Once I've got that, the transition times the original state, which was 160, 140, 180, equaled, so that was SO. This is day 1. I end up with 146, 154, 180. But the question just was, how many vote for Ali? Ali's at the top. So I'll say 146 vote Ali on day 1, okay? Okay, Max decides to withdraw his nominations after 1 day, okay? And the table below shows the proportion of students who change their preference from 1 day to the next for the remaining 6 days. At the end of the 7 days, who is expected to become captain and how many? So who's expected to become captain and how many votes? So you've got to give 2 answers here. So what you want to do, it's 7 days in total, but it's 6 days on this new, we've got to do 6 days on the new transition. So really what you're going to do is you're going to do this transition here, T to the power of 6, but you're going to times it by S1, which was found in the previous question, which you would have done. So just remember S1 was original transition times SO. So we find that. So if I do that, so just make sure, I'm just not going to write out that transition again, but I will write the S1 so you know what numbers you're putting in. 180, was it? Okay, then you end up with 280, 200, and 0. So you have to state who won. Ali with 280 votes. Probably people didn't get the full marks because they're not writing the statement out.